So pandas frames. If you guys remember the pandas frames that were out here, I'm going to leave the video from last time up here. I'll throw this one up as a secondary one. But we dealt with pandas last week because we were getting information out of that data frame that had the pricing, the closing price of everything coming out of that stock ticker, right?
Yeah.
So pandas is going to be similar to the NumPy array that we've used. However, it is used for some fast, flexible expression of data structures as we go through. So it allows us to build relational or labeled data that's both easy and that is easy to use. All right. So what's nice within here is we can have a series, which is a one-dimensional one, or we can have a data frame, which is two-dimensional, meaning that we have two things. And that'll handle things like finance, statistics, social science, engineering, etc. If we were using R, which we would use in machine learning, this would have and hold everything that we would need on top of that. Pandas itself is built on top of NumPy and is intended to integrate within the scientific community and such. So if you are missing values in there, you're going to have what's called NaN, N-A-N, and a floating point, and that's going to get you some data there. I'm trying to think of what it would actually make a little bit of sense here. So say you wanted to print out columns, notice that everything is tabular in a data frame. If you wanted to deal it out in columns as it goes through there, you could do something like 4 column and DF columns, because that's going to pull out all the columns that are in that data frame. And we could see in the series here that a series equals the DF column as it goes through, right? And then we could do something with that series of data. So let's click on Get Starting Tutorials over here. And what kind of data does it handle, right? And so in the data frame, we have columns and we have rows, just like we would in any other table that we dealt with, right? So to start playing with pandas to get started, let's go ahead and get up PyCharm real quick.
Guessing we're going to use the finance stuff that we did last week and kick it into like a table style format instead.
We could, or basically being able to pull things out. So if you remember like close and all of that, we didn't really see that. We needed to actually dive into all those columns. Now we could actually get all the column headers because we know how to deal with that as a data frame.
And let's say you're doing your own custom data frame for this and you're like kicking in your own information, kind of creating your own table. I'm assuming you'd be able to edit whatever the headers are.
Yes.
Okay.
And that's what we're going to do now is create all of that.
That's good.
So let's see here. PyCharm was loading, wasn't it?
I thought it was.
Everything is slow today.
How long have you had this laptop, Jason?
4 years, but it's no slouch.
Okay, just checking.
It's only a Xeon processor with 64 gig of RAM, so it's.
No, you just strike me as the guy to have like a laptop from 13 years ago. Like, yeah, I just never fixed it.
Yeah, to some degree.
I could see it as the thing.
You should have seen his old laptop.
Oh, back when I was in college.
Yeah.
Yeah, that big 17-inch Jobby I had. Oh, that was fun to carry around. Not. Okay, PyCharm's not coming up. Let's try it again.
PyCharm called in today. It's not gonna be here.
I guess.
Feels like PyCharm calls in every time we come to the because did you have this issue Thursday as well, or was that last Tuesday?
Probably. What is going on here?
There.
I don't
Oh, it
want
is
to
update.
update. Just launch it.
I don't want your updates. I just want your services. I can't continue without my updates.
I'm glad this is on the recording.
Putting the pistol on the
Ready to
table.
go.
I'm not
Feel
asking
like
questions.
feel like past managers.
You tell I used to use teach technology. Just control alt delete when it doesn't work.
Yep.
Okay, I see what was going on. It was finishing up the recording from Python.
Okay.
So it was trying to compress it all out.
Even with all that processor, you're still hammering the shit.
Well, something's hammering it. I can tell you that. I don't know what's hammering it right now, but something's
Oh, look at
hammering it.
those 15 Google Chromes.
The task manager apparently.
Evidently, yeah.
It went up very high for a few seconds.
You became the very thing you swore to destroy.
All right, pause recording. Now that I can't even move my mouse, it's slowed down so much. Come on.
Would you like to open
What is
PyCharm?
going on today?
Counter offer.
I wonder,
All right, so we created a new project. I just happened to call this one Pandas just so we could play with it. We will obviously need to install Pandas. So if we come down here in the terminal, we need to pip install Pandas.
They're using cached pandas. Where's my panda cache?
So again, the beauty of this is that we can deal with its data frame. So most of you guys have stored your data in dictionaries to this point, right? We've converted JSON data back over to dictionaries, and dictionaries are handy, but if we do that more as a pandas frame, we can then send that data out very nicely. So we can manipulate it quicker. We can do all sorts of cool stuff. Spit it out to PDF if you wanted to. Okay, so we have pandas installed. To get started with pandas, we want to import it. So import PANDAS as PD. That is the proper import for pandas. Okay, so
PD.
import pandas as PD. And then in this data frame, what we're going to do is copy some kind of data like this. So if we want to create a data frame, we're going to say something like DF, and that's just an abbreviation for data frame. You can use whatever you want. We're going to use PD dot data frame. Oops, data frame. Like that. And then we're passing in whatever we want into this data frame. Now, in this case, we're going to pass in a dictionary of sorts. And I'm just going to copy and paste the one example that they have here. So we have a dictionary, and inside that dictionary, we have a name, and inside that name, we have a list. And in that list, we have a couple different names. We have an age with those 3 ages all in there. We have sex as a list with all of those lists in there. That's our overall dictionary. That all make sense?
Can you zoom in just a little bit on that?
No. Actually can't.
Oh. Fair enough.
I would
Let's
have to
see.
change my font
Shut the light
size.
off and kill that glare.
Something like that. View. There. That easier?
Yeah.
Okay. So again, I just copied and pasted this right off the tutorial so you guys can see what the data frame comes in here and looks. So with this in here, we have our column labels, right, that are going to come in here. So if we look at our DF, for now, we're just going to print DF so we can see what's going on. Print DF. Get rid of this little break thing. All right, so let's run this little program. And if we do our PD, Pandas has no attribute data frame. Did you mean data frame? What did I not spell data frame?
Did you, we're supposed to capitalize the first.
Nice. Thank you. When I hit tab earlier, it did not autocomplete. There we go. And so we have this data frame where it looks like an Excel sheet, right? We have all of our columns, which is name, age, and sex. We have our rows of 0, 1, 2. Okay. And this kind of comes back to when we talked about financials, we could do that. If we wanted to just print our columns, we can do dot columns. And we would get a list-like object of all of our columns. Does everybody remember list-like objects? Right? They look like a list, but not really a list. We need to do what if we wanted to convert that to a list? Pass it into the what function? Yeah, it's really that simple. So we pass it into the list function, and we could get back a true list of all those column headers.
afraid to say the obvious answer.
So it's only gonna touch the first row, basically the headers, so.
No, that's just pulling out the columns that came out of there.
Oh, okay.
So if we wanted our rows, we could print that. We want to get it, right? We have our columns. We want to get out all of our rows. What would our rows actually be called?
Here.
So that is a column, right? If this was in a spreadsheet software, each column in the data frame is going to be a series, meaning here's our name, here's all our names. Here's our age, here's all our ages. Here's our sex, here's all of our sexes. These rows are going to be the other ones that come across this direction, right?
Would we have to use like a for loop to iterate through that, or?
the key is that we have no row names, right? If you look in an Excel, it's just 1, 2, 3, 4, 5, 6, 7, 8. We just have indexes basically on our rows. So you can't pull back your rows here, but you can pull back your column headings, which in this case used all the keys of the dictionary that we passed in. Does that all make sense? Okay. Now, it is a series of data that we have in each one of these columns, and that's what this is saying. Meaning that if we specifically wanted to pull out the column of our DF, and in this case, say age, we could pull out all of our ages and would print all those across, right? So this printed out our list of all of our columns. We're going to hide that one for now. Just run this. And you can see that we get back our information of all the ages. We have the actual ages. And on the name of this particular series is called age. And the type of this is an integer 64. So by default, we're setting it up as a 64-bit integer, which means it can store a lot of data in there, right? So that gets us back to our series that we can see there. If we want to create a series or add information to our pandas frame, we could set something like ages equals a PD series in which we pass the list of all the values and we pass the name of the column that we want to set. Everybody see how we can create that? The idea behind a Python dictionary is that you have a single column, which is all the dictionary values based on that key. So a pandas data frame is very similar to the dictionaries you guys are used to. It's just how we're storing that information.
So we have all this information hard coded in, like we're just using the values from this example at the top, right?
Right.
So
you have this dictionary here.
I'm guessing that there would hopefully be a way for user input to just input that themselves.
You could, I mean, that's what I'm saying is you could set a new column in here, in which case we would say something like, level, right? So level equals PD.series. And this series, we would want to pass in all of the values as a list. So this level would be something like sophomore, freshman, and senior, right? And then after we pass in that series of data, we need to pass in a name for this, or what is this? So we would set our name equal to whatever we want. So name equals student level. I don't know, right? And that whole level now could be added to that data, this pandas data frame inside of there. If we were to just print our level, you could see that we have this as the series data frame that we pulled out, just like we printed out this one down below.
So let's take what we did last week, our stuff with Y Finance, right?
Mm-hmm.
Could we take that information from Y Finance, like say our stock ticker prices, and kick them into a pandas frame?
Everything was coming back as a pandas data frame from Y Finance.
Okay.
So and that's what I'm going to do is try to load up our project from last week where we can actually go look at all our column headers. So if we come back and open up our last project.
Could you get it to change, like let's say with our stock ticker specifically, obviously there's a new closing price every Monday to Friday, right?
Right.
Could you manipulate that frame to, I guess, like automatically update the new information every day or every week, or is that something that we'll cover later?
It wouldn't change that in the frame, right? You have to retrieve that information back from the API. So I'm just creating a new file here real quick called next. I don't want to add it. The idea is I want to go back and get our data that we had in here. So I'm just going to import this in here. Just get this back in here. Matplot here, get our ticker, and our get ticker we needed to call, what was our project here? Get get closing, right? So we called get closing, and we're going to just say Microsoft to get back our ticker here. And this would say closing equals that. All right. And if we print our closing, this is just reusing the code that we did last week. Oh, this is where it's one. Oh, stop. I'm running the wrong one here. Just going back to the real basic sample of going to get the ticker closing. So here's the problem where we got all this list of all of our closing prices, right? We actually want to get that HIST data. So let's look at our HIST. So instead of returning this, let's just steal this out here so we can get the basic information. Okay, we have a stock. That sets up that. For that stock, we want to get our history and we want a specific ticker, and this is going to be Microsoft MSFT. Okay. And at this point, let's just print our HIST that we get back from them. There we go. Now we have a pandas data frame that came back here. Okay. So if we wanted to see all of our columns, we can use our columns. And we would get back a list of all of our columns that went across there.
Okay.
So that's how we could have retrieved that information last week where we were just guessing, basically. All right. If we wanted to pull back a series of all the different ones that were in there, say we wanted to get back all of the close, which is what we wanted, right? So we would have HIST close. This gets us back a series of that information that had the date and the closing price as a tuple that it went through there. Okay. And we can see the name of this column was close and the type was a float 64 so that we could get back that information going through there.
Gotcha.
So how does it have the date and the data?
That is just what was stored in there. So it's almost like a tuple. It was storing a tuple of information in there. Okay. So what's nice with the data frame is that we have all sorts of cool little functions built right into it. In other words, we can actually figure out the max closing price of all this just by typing max.
Oh,
We write our max method and it will just print out
I feel the price.
the max method. Now that's not actually going to work because we want to take that off of our close. So there, and there. And we get back the max closing price out of all that. We could also get back the minimum if we wanted to. Instead of having to put it all into a list, right? Sort it, then either grab the last one or grab the first one. We could just do that immediately with max and min.
So for this one, we would do like a print statement of like the date and the highest closing price if we want to.
We
just
could.
do two separate polls for that.
Exactly.
Okay.
Yep. We could also use describe, which is really handy if you guys are doing some statistical information. So describe will get you back the total count, aka the total ones we got back. It'll give you the mean average, right? Remember, mean is basically means average. The standard deviations between them, the minimum one, the 25%, 50%, 75%, and the max, aka max being the highest.
That's actually really cool.
So tons of statistical information right off the bat.
Yeah.
Then you can build out charts and graphs off all the describing of all that. So instead of you having to calculate all those out, you can just do describe, store all that information, and make those different line graphs that go across your chart
Oh my gosh.
Let's go.
in a hurry.
That's
Right.
really good.
So that all comes from your basic statistics that are in there. You can set up floating points. Let's see, you can read in tabular data. So you can take, say, comma separated values or an Excel sheet, read that into a pandas data frame. Then you can send that out to another one if you wanted to. So you could send it out as HTML or JSON
Oh,
or a PDF document.
So
You can actually send it out.
can also like convert from one thing to another in that way.
Yes. Yep. Yeah, you can use pandas to convert things between that. So the idea is that you could bring in the Titanic here. So Titanic is going to read a CSV and you grab a CSV file and it automatically stored these as all these columns. In which case, if you just want the first 8 columns, you can use head 8, just like if you guys have ever used Linux, right? Head allows you to grab the first 8. This will let you grab the first 8 rows out of that pandas data frame. You could get the D types, which will get you back all the different types that are used inside that column. There's tons and tons of information you can use to pull that back out. If you wanted to pull that or send that out to an Excel sheet, you can simply use Titanic to Excel, give it the name of the Excel sheet, the sheet name you want to store it as, and whether or not you want it indexed by the rows that are going out there.
Hmm.
And if you set the index to something, it will actually store the rows as an actual label.
Gotcha.
All right. So here, if you collect the .info, you could gather a bunch of information about that data frame as well. All right. So what we would want to do is create something like a plot chart going across here. You could import pandas. You import PyPlot, which is what we've done in the past. We get in a bunch of date time information here, where it's storing a bunch of that. We want quick visuals. You can just say air quality, which is the name of this pandas frame, .plot, and it will immediately plot out everything inside of that and chart it. So what does that look like? If we go back to our pandas frame and we import our matplotlib like we did in the first one, let's grab that. Stop there. Here, and we point that, oh yeah, I did pull it in already. So all we would have to do is do something like hist dot what? Anybody remember? Plot. Plot will create the plot. Then we actually need to use plot to show it, right? So dot plot. And then we can do plt dot show.
I believe you've got point up there.
Yeah, that's point. Point.
It's not plotting correctly, is it?
And if we print this and we get it, we get the nice graphs with all the high, lows, charts, everything automatically gets graphed across there.
So like, let's say that you were doing data across like 10 years or some stupid thing like that, where your line will have a lot of deviation.
Right.
Can you have it like, would there be a way to mark like, this is the high, this is the low for that set of data on your graph, or is that?
You could by using describe, you can automatically plot out the
Oh.
describe stuff.
Okay, that'd be cool.
So this one obviously failed, and it failed because there was some other stuff that it couldn't convert here, right? It got through the first couple ones and then it plotted death.
Period with day fruit.
Period, D type is deprecated. Basically, the frame that came back is using an old version of a pandas data frame, and so we would have to convert it to use something else.
Oh, interesting. So could you? So you
It's
could-
actually a future warning. It didn't actually die. These are
So
just warnings.
it succeeded, but it won't succeed for much longer.
Right.
So you would make this and you would just have your whatever your include file is to
Exactly.
use this specific version of pandas or earlier.
Yep. And you can suppress these warning features if you wanted to.
Oh, cool.
So the idea is that we can then automatically plot a bunch of this stuff out, which is pretty cool as we go through and play through that. All right. If you wanted to plot out just one of those series, AKA like what we were wanting to do with just close, we would just pass it that particular one and say plot. So we would say hist. We only want to deal with close, and we just want to plot that one.
Gotcha.
Rerun that.
And
You would get the plotting of those individual pieces. Now, notice at the bottom what the difference is. We got all the dates back now for those 10 days that we were wondering about. Notice that it specifically has 9, 18, and then it jumps back to 15.
Oh, so it just reads in the data. It doesn't worry about.
Right. The reason it does the 9, 18, 15 is marketing days, right?
Yep, weekends. Yeah.
So the weekend was gone, and then we could go ahead and market those individual plots.
So
We would still want to modify it so we'd have an x-axis of our prices,
yeah,
right?
that is really handy.
But notice how much faster it is to use that straight off the data frame
Yeah.
instead of building out your own plot tables.
This is why I didn't show it to us last week, because the assignment would take like 2 minutes.
Something like that, yeah. You could also build out scatter plots if you wanted to. You could build out all sorts of other information. There's a whole way to calculate summary statistics, like we talked about, aggregating all the means, the medians out of there. Describe, obviously, we talked about, gives you all the main ones. You can reshape the way that's laid out. So say you brought in a bunch of these tables like this, right, for Titanic information and this air quality, and you wanted to sort those rows by a given amount,
Oh,
right? So you could just tell it to sort values by, and then whatever ones you want it to sort by. And then you could either tell it ascending is true or false. And if you use head, it's automatically going to grab the first 5 results.
oh.
Unless you tell it you want 8, and then you would pass 8 in there.
So not using dot head, we'll just return everything. Dot head with nothing, we'll return the first 5.
First 5. Yep,
And
by
if it's
default.
specified anyway.
Yes. Yes, you should be able to use tail to get the last results.
Can you return less than 5 or like is the 5?
Yeah, you would have to specify it. 5 is just default.
Yeah.
So if you remember like a normal function in Python, if you don't give it that variable, you have to say it's by default, it's 5.
I didn't know if it was like 5 was the lowest that it could go.
Huh.
You can just pull the top one if you wanted.
That is really cool.
What's other really handy is using or combining tables from different places. So if you need to combine multiple data charts together, which you guys may be doing with your APIs, you can use this to combine those two together. So if you wanted to combine 2 of these tables into one big table, you can use concat, in which case it would concatenate them all together and put them in the way you want it to be.
Could you use that to override like previous data? So let's say we get the Microsoft closing for today, right?
Right.
And we store it as its own table. And then we create a separate function where it's like, hey, here's the closing price for tomorrow, and then we use that concat. Would it just override it, or would it just?
It would add it to the bottom if it was concatenating.
Okay.
Yep. What's really nice is time data. So most of what you're going to want, or what you guys will be playing with, is time data series, which in a time data series, you pull out a date time, and you've got all these date times that go down, and then you can specify out, AKA that is what we're doing with our financial prices, right? Those are a time series data. We have a timestamp of exactly what it was on this date and time. Which means we can do date time stuff on top of that. AKA we want the month of October. You can immediately tell it month, October, boom, pulls out just the month of October. So it's really cool to use pandas frames to kind of manipulate things, manipulate textual data, manipulate charts, graphs. If you're doing any kind of math, then it's really handy to move that through. All right.